Welcome. In this video I'm going to show you how you can perform a one sample sign test using R in my stikpetR library. I'm using Jupyter Notebook, but the R code should also work with RStudio, for example. This one sample sign test is a test that can test for a specific median. It's an alternative for a one sample Wilcoxon signed rank test or a trinomial test. To show you how this can be done with my library, I have separate videos on if you don't want to use my library. I'll load in some example data. I don't actually need all the data, I only need one field, so let's use the account sci, which is short for account scientific, which shows the responses for how scientific accounting is according to the respondent. I stored those under ord field, and from the counts you can see that, for example, 348 people thought it was not too scientific. Let's also store those codes from not scientific at all to very scientific separately as a coding. Now my library is available not on CRAN, so you can use DevTools and then install GitHub, and then you can install it straight from my GitHub account. I've already of course installed it myself, so I only need to load the library. The function of interest is TS, which is short for test, and then sign for sign test, and OS for one sample. It has three input parameters. Well, one is a must, the data itself, of course, which should not be a panda series but a vector with the data. The levels, in case for non-numerical data, that's that coding. And if you want, you can specify the hypothesized median. If you don't specify it, the mid-range will be used, so it simply takes the maximum plus the minimum and divides it by 2. Alright, and that's actually all you need. So you can just enter the function's name, set the ord field and the coding in my case, and it nicely gives you as a in return the hypothesized median used, the p-value, so the significance, and a small description of the test that was used. Now this is below 0.05, which is the usual threshold, so therefore we would reject the null hypothesis, and therefore the median is significantly different from 2.5. Alright, I hope this video was helpful, and thank you for watching.